Hello students, welcome to my channel Shalini Tutorial Classes. Today we are going to do a chapter from geography, that is topographical maps. Okay. Now before moving ahead with topographical maps, there would be a question in your mind, what is this topographical survey maps? Because right from your junior classes you have been used to two kind of maps, that is physical map and political map. Now physical maps are the ones where you have been marking all the land features like mountains, valley, plateaus, rivers, oceans and everything. And political map deals with the important places, states, cities, yes, towns, continents. So these are the places one, and the different kind of landforms, relief features and all you have been marking, which is termed as physical map. Now from class 9 onwards you would be seeing a very different kind of map in your textbooks, which is called as topographical survey maps. Okay, now these topographical maps, they use contour lines to show the elevations or the depths of a particular place. So actually if we want to say what is a topographical maps and what is the difference between a topographical map and a regular map, the topographical maps, it gives you a three-dimensional landscape on a two-dimensional paper. Yes or no? On a map is what? A kind of a sheet, a kind of a paper which can only show you the two dimensions only. But actually when you see that, actually that part is in a three-dimensional figure on the ground. When you have a look of that, the mountains, we can just point out where that mountain is on a map. But actually when you look at on the ground surface, there's a particular length, width and the height of that mountain and everything is there, which all the details you can't present on a normal sheet of a map. Okay, so topographical maps are the ones which gives you the three-dimensional figure of a particular object. Now when we deal with maps, we deal with two kind of maps, large scale map and small scale map. Now large scale map means what? They are the maps which are having small area with detailed information. Okay, whereas small scale maps, they are large areas but gives us a less information. To make it more clear, let me give you one example, a relevant example. Let us take your own school. Okay, when you are provided with your school map, the or you can say a kind of a sketch of your school map, and you are asked to point out where your class is. So can you give me a detailed information over there? No, you can just point out to which floor your class is situated, to which part of the building, school building and all. But if I give you your sketch of your own class, then very easily you can point out over there which row and column do you sit, your seat is situated, how many windows are there, where is the blackboard situated, yes or no, and where is the entry and exit doors to your classroom. So you can give me a detailed information over there. That means when I am taking a big area, large area of the whole school, then the informations are very limited. And on the contrast, when I am taking a very small area, suppose that is the classroom only, then you can give me a very detailed picturization of the whole classroom, where everything is placed and everything. You are very clear. Got it? So large scale maps, small areas but with detailed information, and small scale map, the areas are large, and because the area is large, the information is very less detailing. Okay, so in this manner Topographical maps can be classified as a large scale, detailed and quantitative representation of relief using contour lines. Okay, now these topographical maps in early times, they were used by the military people according to when they were planning for the battle and all. So they need all the vital information, like where they can hide, where they can find a cave, or where there are mountains or river to cross. So they need a very detailed information. At that time they used to use this topographical survey maps. And even like the architectures, while having the construction work, the mining time, okay, the civil engineers and everybody, they use the topographical maps to get a detailed information of a small area, so that they can do their planning accordingly. Okay, so in a very short, if I say, how can you define topographical maps? A topographic map is a type of a map characterized by large scale, detail and quantitative representation of relief, usually using contour lines. Understood? Very simple, nothing to memorize. Just what it is. Topographical maps are what? Large scale maps, and giving us a detailed information. And what do they represent? They represent the relief features using the contour lines. I hope till here it's clear to you. Okay, now moving ahead, in this topo sheets we are going to deal with many points, topics like 4-figure grid reference, 6-figure grid reference, about the heights, about the contours, how to use the scale in a topography, the distance, the area, directions, patterns, and many more. There are many more topics. It's a vast topic, so we will segregate them in different videos and you will be able to understand them better. The first, let us talk about the grid references. Okay, when you in a topo sheet, when you see, you can see there are horizontal and vertical lines present over there. Okay, so a grid is what? A grid is actually a setup of lines to locate exact location of a place on a map. Okay, now the vertical lines which you are seeing in the topo sheet maps, they are called as eastings, whereas the horizontal lines which you see on the map, they are called as northings. Okay, so eastings are numbered from west to east, whereas northings are numbered from south to north. Okay, now see, or in better way, the eastings you can understand for more of your clarifications. Sorry, eastings run from left to right and northings run from bottom to the top. Okay, and when you mark, you always mark the eastings the first. That means the one which is numbered from left to right, you will always mark those numbers the first. Sorry. And then you are going to number the northings. See, suppose I want you to find out the grid of this dot. So what will be the grid reference? First you will mark the eastings. So in the eastings to this red dot, which one is to the left of it? The line is 4, 3, 43. Okay, and what are the digits which are present according to the northings? The digits are 2, 3. Can you see the lines? So for the eastings, we will take the eastings first. So the line which is denoted just prior to the exact location which we want to mark is 4, 3, and the northing is 2, 3. So the grid reference for this will be 4, 3, 2, 3. Clear? Now let's do some more example kinds. Like suppose over here I have a shaded region and I want you people to find out the grid. So first of all, you have to understand what you will take the first two digits and then the next. So first is your eastings. So in that way, just prior to the shaded region, which line is coming, which easting is there? 5, 7, 57. And when we talk about the northings, we will move from bottom to the top. So which line will be coming before to the shaded region? It is 8 to 82. You can see in the slide. So your grid reference for this will be 5782. I hope children it's clear to you. Now similarly, we will do the 6-figure grid reference. So I'll be sharing a very easy trick with you all people to find out how to find the 6-figure grid reference, because 4-figure very easily you can do, but the 6-figure some children find it very difficult. Now let us move on. 6-figure, what we do, when you find out the grid 4-figure grid reference, in that only will be more specified, then it is called as 6-figure. Suppose the box which is marked, I want the 4-figure reference of this, then what would be my answer? The eastings 62 and the northings 33. So my 4-figure reference will be 6233. Now in this, if I want that the one in that shaded region, the one small patch is there which is much more darker, I want to find out the 6-figure reference of this, then what I'll do, there is one method, like that whole box, you using your ruler, you can point out and divide that whole box into equal 10 parts. Like you all know, the topographical each that grid is equals to 2 centimeter. That is the scale which we take, okay, which I will be explaining in the next topic. Okay, so each grid is equal to the measurement of 2 centimeter. So what we can do, that we can subdivide them. You can use a ruler, or if with practice, when you get used to this, then within your eye estimation also you can also do that, okay. But as a beginner, when you are starting, I would prefer that the whole box you should divide it into small dots you can place over there with the divisions, and the line, like in the slide you can see it has been divided from 0 to 10, the box. Now again in that small grid only, you are again having kind of a easting and the northing. So similar way, like first we did for the 4-figure, we took the eastings, no, that is 6-2. So in the same pattern, which would be the sub number which is coming just before to the dark shaded one, that is 5. Yes. So, and similarly in the northings, when we come, we see the grid reference which is coming along over there is 3. So what would be my answer? First the easting, that is 6-2, and the sub part, that is 5, and then I'll move to the northings, that is 33, and then the sub part which is equals to 4. Now suppose children, for me sorry, it could be like to you it is 4, and to another boy maybe it has seemed to be 3, because it is just an internal eye estimation. So not to worry of that. The council gives you a benefit of plus minus of 1 point. Okay, that means if suppose the inner division is 4 and you write 3, you will get a mark over there. But if it is 4 and you are writing 2, then you won't get the marks. Am I clear, children? The 4-figure reference should be absolutely correct. What should be the answer? And the internal grading, because it's an eye estimation form, maybe to me it seemed as 3 and to you it might be seemed as 4. So a plus 1 or minus 1 marking. So if answer is 3, either you write 4 or the exact answer the 3, or 4 or 2. you will be given a mark. But the 3 is there and you should not write over there 5 or 6. Understood? So because it is an eye estimation, 1 plus minus marking is provided. So this is the way how to find out the 6-figure grid reference. So to be more precise, see, a one particular grid been taken and been divided equally in 10 parts, and then whichever dot, like this dot is there, okay, so it's on that line, suppose it's coming on to that line only, then you can consider that same line, that is 5 over here. So the eastings over here are 12, and then the point is 5, and the northing is 0, 4, and the pointing for that, once you did for easting the sub pointing, similarly you did the sub pointing for the northings also. So for the northing, when you did the sub pointing in the second figure, so let's take one more example to understand it more better. Suppose this is the yellow shaded region which I want you all people to mark, and this the green dot over there, I need the 6-figure reference of that green dot. So what you will do, you will first consider the eastings. So in my easting it is 1, 9, and when you do the sub pointing in the easting wise, it is coming around 6, okay, and then I will take the northings, that is equals to 4, 3, and in the same manner if I take the sub points, then it is coming around 8. So my grid reference for that would be 1, 9, 6, 4, 3, 8. That is 1, 9, 6, 4, 3, 8. This would be the 6-figure grid reference of that particular green arrow point. I hope children it's clear to you all. Now moving ahead, we discussed this coordinate, the grid and everything. Now we will move to a new topic, that is direction, scale and distance. How do you find out the direction and the distance in the topographical maps? Now see, as you are very well aware, the cardinal directions, yes, the main are the north, south, east and west, and the intermediate directions are called as the northeast, southeast, southwest and the northwest. The same one we would follow in the topographical maps. Now how? Let me just explain you. Suppose I want you people to find the direction of point D from point K. Okay, what I said, mark my questions. I said, what is the direction of point D from point K? Let it be any of the places. In topographical maps you have different places named over there. So suppose Gulabganj or Hari Om Nagar or something like that. Okay, so and if I ask you that give me the direction, so what you have to do, you have to first find out from which reference to which reference the direction is being asked. Okay, so suppose if from K to D I am asking, so at the point K itself you have to imagine this cardinal directions compass, that is the north, south, east, west. North is always pointed towards up. So what you will do, thinking of that compass direction at the point K, you will imagine to which direction is this point D coming. So when we assume it over here, what we find, it is in the pointing in the northwest direction. So my answer will be that the point D lies in the northwest west direction from the point K. Now suppose if I ask you give me the direction of point K from point D, from D, so we have to imagine this compass direction at point D. Okay, so what will happen, it is pointing, if you assume it at D, then this K is lying in the southeast direction. So the answer will be the point K lies in the southeast direction from the point D. Clear? So similarly you can in your topo sheets only, you can take two different places and you can practice like this the direction. Just you have to keep in mind that the north is always directed towards the top, Okay, so keeping that in mind, you have your cardinal compass, imagination, and you try, or you with a pencil over there with a small this arrow marking. If you point out the main north, south, east, west at that point, then you can easily find out the intermediate directions between them. Clear? And children, I won't like, it's been advised not to make your topo sheets dirty, or no scribbling over theirs, because they are being taken back for the reuse of that. So I would prefer use only pencil, do not use pen, and make sure that after your work is done, you erase it and return to your teacher back in the exams. Okay, because in exams, when the topo sheets are given, you have been they have been taken back. So don't use your pen and make it very shabby, because they have to be preserved for further uses. Okay, so use a pencil and erase it, and let the sheet be very neat and clean when you return. So in this way, you can find the direction on a map using the compass bearing. Now the scales, coming to the next point, is scales. Now scales in topographical maps, we deal with two kind of scales: linear or graphical scale, and representative fraction. Okay, now linear, as while doing the grid reference, I informed you that each grid is equals to 2 centimeter. Okay, the measurement, and that one grid 2 centimeter is equivalent to 1 kilometer on the ground. That means 2 centimeter on your map is equivalent to the 1 kilometer distance on the ground. So what will be this 2 centimeter equals to 1 kilometer? This is called as linear scale. Okay, just a line which you are mentioning, this is called a linear scale. And when you with respect to the map and the ground, when you find the ratio, that is called as representative fraction. That is, what does representative fraction? It is the ratio of the distance on the map to the distance of on the ground. So 2 centimeter by 1 kilometer, this ratio when I write, and because it is 1 kilometer, and in maths you have always been told that both the units should be the same. So we have to convert 1 kilometer in centimeter. That means 2 centimeter is equals to 1 after 50 centimeters. That means 1 by 50,000. So the representative fraction would be equal to 1 is to 50,000. I explained you how did it came. No need to learn this value. It's as simple. Only if you know the linear scale, that is 2 centimeter is equal to 1 kilometer, you can easily find out what is your representative fraction. So when I am mentioning it in 2 centimeter equals to 1 kilometer, then it is my linear scale. And when it is represented as 1 is to 50,000, then it is termed as representative fraction. I hope the scale part is clear. Now coming up, you have seen in the questions coming up, like to find the area, to calculate the area of a particular place. Then what you have to do is, you have to see that area is spread out in how many grid references. Okay, so suppose it is in one grid reference only. So as we know that the linear scale is 2 centimeter equals to 1 kilometer. So for the area you need both the length and the breadth. So because it's a square, the grid reference is a square, so it will be equal. All the sides would be equal, so the L into it will be in the form of a square. So area for a square is side whole square. So what will be, suppose if you are taking one grid reference only, the area is been asked, that means it is 2 centimeter into 2 centimeter, and you can convert it into kilometers. Then easily you can find out. So similarly, what we will do, we will keep this scale in our mind, and in the map how many grid references or the distance they are covering up, you will find that length. Okay, and sometime if it is in a very straight line pattern, you can also use your measuring scale. Okay, and you can measure the distance between those 2 points. Suppose if you are asked to find out the area of the river which is flowing in that particular particular section, so you have to first see how many grid references are being occupied in that, and according to that each box is equals to 2 centimeters. So if suppose there are 6 boxes, then how many centimeters the length would be? 6 into 2. And similarly for the breadth, if suppose 4 boxes are there, that means the breadth will be equal to 4 into 2. Okay, because each grid reference is equals to 2 centimeter. So in this manner, what you have to do, you have to first of all find out how many grid references are there, and each grid reference equals to 2 centimeter. So in that way you can calculate the length and the breadth, and then area formula is what? Length into breadth. So area, you will put up that length and the breadth, but make sure that if you are putting it in centimeters, then the area you will be getting in centimeter. Both it should be centimeter, but overall when you give the answer, it should be always in kilometer square, because you are giving me the area on the ground. So the ground the units are kilometers. So what you have to do, you have to convert that scale form depending how much length it is taking and breadth it is taking, keeping on mind that each the scale is 2 centimeter equals to 1 kilometer. So once the length and the breadth you get, you convert it into kilometers, okay, and then you find out the area. Just on the slide I have an example. Suppose my length in the centimeter has come 12 centimeter. So to convert it into kilometer, okay, the next topic we will be discussing is about the drainage, how to find out the direction in a given river and the bank of that river, and what are the different drainage patterns and all. We are going to discuss that. See, when you look at the topo maps, you can see the streams over there, okay, and in some of the streams you can see a black arrow mark pointing out over there. So that black arrow mark, it points the direction to which that river is flowing. Now in some cases you might not find that black arrow, and maybe or it is there, you are unable to locate where it is situated. In such scenarios, what you will do, you will see the numbers which are written on the topo sheets, which are called as contour heights and or the spot heights. Okay, they are the 3-digit numbers written over there in a black color, like 174, 297, like this. They are called as spot heights or contour intervals, which I'll explain you later up, coming up, what is the difference between contours and spot heights. I'll be moving ahead. So when you see those numbers written on the topo sheets, those numbers, from that you can differentiate which is the highland and which is the lowland. The higher the number which is in greater the number, that means that land is a highland, height is more, and where the number is less, that height is less, it is a low level. So water always flows from a highland to a lowland. So in that way you can find out the direction to which the river is flowing. Now once you are able to identify the direction, then what you have to do, observe yourself that you are flowing in the same path. Like suppose in this river, it is moving from right to left, okay. So if I will place myself also in the same stream in the river, then what will happen, my left hand will depict the left bank of the river, and my right hand will depict the right bank of the river. So once you are known with the direction of the river, then you place yourself in the same path, in the same flow of the river, and you can easily identify according to your right hand and left hand. You can identify which one is the right bank of the river and which one is the left bank of the river, okay. So that means in this slide, according to this slide, if the direction is from right to left, that means if I am on the stream itself placing myself, that means the arrow, the red arrow mark is to the left bank of the river. It is pointing to the left bank of the river, and the right bank of the river is my right hand side one. So in this way you can identify which one is your right bank and which one is your left bank of the river. Now moving ahead, the different types of patterns of the drainage. There are basically 4 types. They are dendritic, trellis, radial, and disappearing. Now discussing each one of them. Now look at the slide. I have some pictures over here to make it more clear. You can see the dendritic. Have a look over there. The dendritic is kind of a branch of a tree. They look like a tree branches. How they have the look, see, all like you while drawing, you draw a tree, no, the branches and all. Whereas trellis, you can see the drainage patterns, they are in parallel to each other. They are parallel to each other. They are not intersecting each other. Such pattern is called as trellised. Whereas in radial, what happens? All the drainage pattern seems to coming towards a point. They all are converging towards a particular point or a particular place. Then it is called as radial drainage. And if you see the drainage patterns, they are there, and after some time you are unable to locate their patterns. They are disappeared. Okay, they are vanished. That means the stream is no more. The water has gone dry. Okay, or the water has gone to under the heavy rocks, and it is kind of not a soily area, and it is an arid zone, and all the water has percolated to the ground. That kind of drainage patterns are known as disappearing drainage. So there are 4 kinds of drainage patterns: dendritic, where the pattern is like of a branch of a tree; trellis, in which the branches are parallel to each other; radial, where the pattern seems to converging towards a point; and disappearing means after the flows begin, after a particular area moving, they are you can't locate the stream continuing. Either they are, the water is it means that the water is dry, means there is no water, or it is a seasonal river, or it is a kind of an arid region with lots of rocks and pebbles, and due to that the water has percolated deep inside the soil. Okay, so right now, if we want to have a quick review of what we have done till now, we have discussed about the eastings, which runs from west to east; northings, which run from south to north. And whenever you are writing a grid reference, always you have to mention the eastings the first and then the northings. Okay children, if any confusion, you always remember the alphabetic order. In A to, if alphabetically you see E comes first, then the N, therefore eastings will be marked the first, then the northings. And in that way you can give the 4-figure grid reference. And for the 6-figure, what you have to do, I estimation, that particular grid itself you have to divide into 10 parts, and after pointing the eastings, you have to point the intermediate of the easting sides, the I estimation point, and similarly after pointing the northings, you have to take an I estimation of the northing. In this way you can mark the 6-figure grid reference. Then we have discussed about the scale. There are 2 kinds of scale: linear scale, which is also called as graphical scale, and the other one is representative fraction. Now linear scale means 2 centimeter equals to 1 kilometer. This is what we consider. That means 2 centimeter equals to 1 kilometer means what? 2 centimeter on the map is equivalent to the 1 kilometer on the ground. And representative fraction is the same when we consider it in the form of a ratio. So representative fraction is equals to the distance on the map by distance on the ground, which if you calculate 2 centimeter by 1 kilometer, which comes equals to 1:50,000. Then we have discussed how to find out the direction of the river, and how to find out which bank of the river is situated a particular landform, how to identify which bank of the river, differentiate between them. And then we discuss the different types of drainage patterns. There are 4 types: dendritic, trellis, radial, and disappearing. So dendritic is the one where the branches of the pattern is in the form of a tree. Trellis, it is a parallel, moving parallel or perpendicular kind. Radial, where the patterns are seeming to converging to a particular point. And disappearing means the pattern, the drainage after some time vanishes and gets disappeared. Okay, So I hope this video will be effective for you, and the other topics of the topographical maps are being discussed in my the next part of the topographical sheets. So you can have a look of my part 2 and part 3 for the other topics to be discussed. Thank you for watching, and if you like it and you are happy with the performance, then please subscribe the channel, share it, and do comment it. Thank you and have a nice day.